You're listening to the N2K Space Network.
Risk and compliance shouldn't slow your business down. Hyperproof helps you automate controls, integrate real-time risk workflows, and build a centralized system of trust so your teams can focus on growth, not spreadsheets. From faster audits to stronger stakeholder confidence, Hyperproof gives you the business advantage of smarter compliance. Visit www.hyperproof.io to see how leading teams are transforming their GRC programs. At Thales, they know cybersecurity can be tough and you can't protect everything. But with Thales, you can secure what matters most. With Thales's industry-leading platforms, you can protect critical applications, data, and identities, anywhere and at scale with the highest ROI. That's why the most trusted brands and largest banks, retailers, and healthcare companies in the world rely on Thales to protect what matters most: applications, data, and identity. That's Thales. Thales. Learn more at thalesgroup.com/cyber.
When satellites burn up upon re-entering Earth's atmosphere, they release particles and gases, including metals like aluminum, which may affect atmospheric chemistry. And this process, known as atmospheric ablation, is still poorly understood. But early evidence does suggest that metal content in the atmosphere is rising. Should we be concerned? Let's find out more. I'm Maria Varmazes, and this is T-Minus Deep Space. To address the uncertainties around atmospheric ablation, the UK Space Agency commissioned 3 targeted studies to investigate the potential impacts of satellite re-entry. I spoke to Professor Ming-Kwan Kim from the University of Southampton about his findings. Dr. Kim, thank you so much for coming back on the show. It's been about a year. I'm glad to see you again.
Yes, it's great to see you again, Maria. So we finished our initial study funded by the UK Space Agency recently. Yep. And we publicly released our findings recently through the UK Space Agency, the public blog.
That's wonderful, because that is... Indeed, when we last spoke, you were very kind in telling me, listen, wait till it's all released. And so I've been sort of eagerly awaiting the news that it's public now. So here I am, very eagerly. I'm a student sitting down going, I really want to learn. So let's start first with the event at which I think a lot of this your work has been recently unveiled. Let's start with that to sort of set the scene. When and where was that, and what happened there?
So after we finished the study funded by the UK Space Agency, so we produced really long document. It's still over the couple hundred pages. So that is the detailing all of our findings. So, but we understand it is very difficult to read all of the document. So with the support with the UK Space Agency, we actually organized the workshop to disseminating our findings with the conjunction with the Sustainability Summit organized by the Secure World Foundation. So
right.
On the workshop, we actually summarizing all of the 4 studies. So the one is from us, one is from the Durham University, one is from the University of the Leeds, one is from the Belstead, which is private company. So the workshop is basically the disseminating what we found it, and also we hope the community can use our research finding as the foundation for the further study.
Excellent. Excellent. So I'm going to narrow the scope because it sounds like there's a lot more conversations I need to have, but I'm going to narrow the scope specifically to what you and your research team, what you all worked on. So please let's review for folks who may have forgotten or didn't listen to our last episode. What were you specifically researching?
So what we done through these studies, we study about the risk of the current, the practice to disposing the satellite. So we know the space debris is the big issue. So to mitigate the space debris problems, the international community, they have the regulation to the deorbiting the satellite within the 25 years. Recently changed to the 5 years by the US, but the current practice is the best way to removing from the orbit is the atmospheric reentry. The other means is the burning.
Yeah.
So our study is basically to start with a simple questioning: is it environmentally safe way? If we burn the satellite at the high altitude or the upper atmosphere, could it cause any significant environmental impact? We also have the experience for the global climate changes, so we don't want to make any similar mistake again. So that is our starting point.
That is quite a starting point. Anything that we should know that was not in scope of this investigation, just for our context?
Yeah, so this is like a very complicated the problem. So basically through this study, we don't want to find the solutions. So what we want to understand through this study is basically the risk of these problems and what potential the problem can be caused by this kind of the practice, and what is the research gap we have, and what is the direction we have to push the kind of the area into the next level. So that is the main envelope of our study.
Sounds great. If you don't mind, could you walk me through all of those? I know it's a lot, but I'm sure it's all top of mind for you right now. So walk me through all that, because I really am eager to find out.
So the first, we have to understand what is the potential risk of this one. Obviously, it is a really complicated problems. So we have to simplify the situation, because the problem is every satellite is the unique design. They have the unique the shape, the unique the composition of the material. So we have to invent some genetic satellite, which is the most popular. So we using the one satellite and to estimate, what if this satellite is the bond, how much the metal oxide can be produced, and we predicting it is basically the metal oxide is the environmentally the toxic by decomposing the ozone. So we estimated how much ozone can be destroyed by the one satellite. So based on our very rough estimation, it is somewhere around 6 to 8 tons for the one satellite. So
6 to 8 tons from one satellite.
Yeah, so it is not large amount because of the Earth is quite big.
Yeah, the Earth is huge. Okay, yes, granted, yes.
So don't be panicked. So we have plenty of the ozone. But some of the constellations, we call these the mega constellations. So they plan to go 40,000, 50,000. So there's a large number of the satellite, and often their lifetime is 4 to 5 years. So literally means the one big mega constellation, they have to burn about 10,000 satellites annually.
Yeah.
So which have the simple mass, it is about 60,000 to 80,000 tons. It seems like a large number. It's actually not the large. It's less than 1% of the ozone can be destroyed by the one constellations.
Still.
Yeah. So
yeah. I was going to say the scale is hard, I think, for an average person to wrap their head around, because we're talking such massive numbers and amounts. So thank you for that percentage. That's very important.
Yeah, so easy translations to understand normal people. Basically, the one mega constellations can impact 1% of the ozone layer. If we have the two mega constellations, literally we have the 2% of the ozone layer deflections. And there are some study done by the WHO a while ago. Basically, the 1% ozone layer deflection is to literally translate into the 1% increase of the skin cancer rate.
Interesting.
So if
Not
we
desirable.
So if we increase to 1%, basically it is representing about the 1,000 souls.
Wow.
So
my goodness. That's important context, honestly. That's something that you mentioned when I spoke to you last year was also about how long I'm summarizing this poorly, I apologize. How long things remain in the upper stratosphere, because that was also, did your research cover that as well?
Yeah, so we do some very brief research because of first we have to understand what we don't know.
That's right.
In the
yes.
context. So we call this the known unknown and the unknown unknown. So
Rumsfeld honors, yes. Yes.
So because of this area is so complex, so the predictions to how long it takes to the particle coming down is varying from which model we're using it. It's varying from the 30 years prediction from some of the researchers and the 4 to 5 years prediction from some of the other researchers, including us. So you can get judging. One hand is the 3 decade, other hand is the half decade. So still there are some unknown. So basically that is the role of the scientist like me to improve the accuracy. So it's like a weather forecast.
Yeah, no, this area, so much about this realm is just completely unknown. So it must be fascinating for you to be studying this frontier, frankly, and just learning about something that we've just known very little about.
Yeah. So honestly, the community has the good knowledge related to this area, but the problem is that they are not the organized well. So this is our first problems from the space, the ages. So we have the knowledge from the different area, but we didn't concentrate those knowledge to tackle this problem. So
we'll be right back.
And now, a word from our sponsor, ThreatLocker, the powerful zero-trust enterprise solution that stops ransomware in its tracks. Allow Listing is a deny-by-default software that makes application control simple and fast. Ring fencing is an application containment strategy, ensuring apps can only access the files, registry keys, network resources, and other applications they truly need to function. Shut out cybercriminals with world-class endpoint protection from ThreatLocker. What's your 2 a.m. security worry? Is it, do I have the right controls in place? Maybe, are my vendors secure? Or the one that really keeps you up at night, how do I get out from under these old tools and manual processes? That's where Vanta comes in. Vanta automates the manual work so you can stop sweating over spreadsheets, chasing audit evidence, and filling out endless questionnaires. Their trust management platform continuously monitors your systems, centralizes your data, and simplifies your security at scale. And it fits right into your workflows, using AI to streamline evidence collection, flag risks, and keep your program audit ready, all the time. With Vanta, you get everything you need to move faster, scale confidently, and finally, get back to sleep. Get started at vanta.com/cyber. That's VANTA.com/cyber.
So there's a lot of things that we still don't know, and I'm sure that is a lot of what you are thinking about and moving forward. So what is your next step from here? What are you looking at next?
So basically, what we want is we want to make some genetic case. Because of what I want is to help all of the community to focus to address these problems. So currently, everyone has in their different view, different assumptions because of the complexity of the problem. So therefore, we want to basically propose some of the genetic scenario with the genetic, the configuration of the satellite. For that, we are consulting with the industries. So we're just consulting the different industry to say, okay, the genetic, the satellite configurations could be representing your system, your missions. So then we can focus on the one simplified scenario to see, okay, what happened under this scenario. Whether this is the problem for the next 10 years, or 20 years, or 100 years.
That's right. Yeah, mitigation is that is the place where my mind goes, is how does one mitigate this? And that is we're figuring that part out yet. So I won't ask, because I know it's like we're still figuring that out. I'm curious how your discussions have gone with industry so far. What have you been hearing?
So the industry is the very keen to support this problem. So because of these are directly related to their operations. So the problem is the design detail. So industry, they don't want to rebuild their design detail, but they still want to contribute in it. So therefore, our solution is, okay, let's see the generating some genetic satellite without rebuilding their detailed design. Then later, they can optimize the satellite or tailor the satellite configuration to the actual satellite to predicting their emissions. But our first step is literally consulting with them and to basically configure like a genetic representative the satellite model.
Are there certain composites or elements that are maybe more of a problematic? Is aluminum a really big one? Like, I'm just curious. Is there any conclusion we can draw, or is that just completely too?
Basically, we released some of the top 5, top 10. We call these the bad guys. So because of that, there are many different species. We have more than 100 different byproducts. So we have to prioritize, okay, which one is the most problematic. So definitely the top one is the metal oxide.
Yep.
So is the aluminum oxide is pretty much the top one because of they are dominant by the mass. And the silicon oxide, this is the other one. And the another one is like lithium oxide or the manganese oxide, magnesium oxide. The other oxide is not the critical, but the problem of the aluminum oxide is not just the aluminum oxide. Basically, that is the impurity. So aluminum oxide alone itself is very stable. But if there's some impurity in there, these guys act like awesome badly. Basically.
Interesting.
Yeah.
Huh. Wow. Oh, so there are so many different implications of this, and I'm just going to be so fascinated to hear how this resonates with a lot of different, not just industries, but other researchers, and because there's just a lot. I'm just thinking material scientists, their heads must be really, really spinning. So
when I communicate with the public to understand this problem, so I open the explain using the cook. So this problem is very similar to the cook. So I'm not good cook. So when I have the same ingredient with my wife, she's actually good cook. So if I having the same ingredient like a meat, so same recipe, but slightly different way to cook. They have the different taste. For example, if we have the same beef, whether we cook the grill, like a steak, or whether we're using the French cooking style like a confit, you can see the taste is very different. Texture is very different. So which means same satellite, how we burn it, how we cooking it. So our taste, like a byproduct, is very different. So what we scientists is like me, we try to do is finding the best recipe to minimize those toxic product.
So it is to be continued to find out what that recipe is for optimal cooking of the satellite state. But the work continues. But I'm so fascinated by what you have already found. Because I have to tell you, I think of all the conversations that I have had, what I've learned from you, I have told to so many people who are not interested in space whatsoever, because it affects everybody. It affects our whole planet, and I've had a lot of fascinating conversations with people about, well, what's the difference between a satellite and just a random space rock coming in? It's just really interesting hearing how people are thinking about it. So it's so cool that you're researching this.
Yeah, and also through the study, we also figured out it is the very challenging to set some regulations. Because of this problem is not just in the space, it happened in the ground. So
that's right.
The space obviously governed by the space law, the UN's the Outer Space Treaty. If it comes down, it's gonna be governed by the individual countries. Then who's gonna be setting regulations, how they can be enforcing it. So this kind of the thing is the other kind of the difficulties.
Yeah. Regulations are extremely, extremely difficult. Sorry, I didn't mean to interrupt you. I know you were mid-thought. Yeah. Sorry.
So what we understand is the challenge is actually the timing. So normally, once we find the scientific evidence, we set the regulations, we implying it, we finding the mitigation strategy. This takes a really long cycle.
Yeah.
But this kind of the problems, we don't have such elegant timeline. So basically, we have to do the both in the parallel.
It's always when it gets to the implementation phase with a lot of things where it gets very tricky. So my sympathies. I'm curious if I recognize this is probably a little out of scope, but a lot of our listeners are in the space industry. So is there anything that you specifically want to tell them, want them to know? I suppose a call to action may be a bit much, but if there is one, if there's anything you want to say to them specifically.
So basically, we try to do some simple survey through the space industry to basically create most representative scenarios and the satellite configurations. So we try to disseminate in some of our initial survey to basically, okay, this is the satellite, whether it is the representative your satellite, yes or no. Basically, we have the simple questions and also try to create some of the generic scenario to whether it's representing your scenarios, yes or no. So based on that is basically the feedback from the industry, from the academia and the government. We try to basically create most reliable or representative the scenario for all of the industry, all of the people.
So that sounds like something that maybe we can share with our audience so they can respond to that. Okay, I will make sure that we include that as well. Well, is there anything else that you would like to leave the audience with since we're coming up on time? I want to give you the final word. Anything else? Yeah, so
we understand this is the problem, which we don't know whether it could be problems or not. So, but it's basically this is some of the area we need to having some the support from the community. So also we have to tackle this one together. So it is the two big problems solved by the one university, is solved by the one company. So we have to tackle this problem together because this is not just done by the scientists or engineers, also need to done by the policymakers and the regulation makers. So once we get the data showing, okay, this is really problems, we literally make the technology ready. Okay, this is our mitigations. Okay, how this is solve the problem, and we also try to set some small international like a working group or small community, basically to do some brainstorming. Okay, how we can solve the problem, what data exchange. Okay, which model is the better, and how we can focus our effort to tackle this problem together.
Oh, fascinating. Well, thank you, Professor Kim. Thank you for sharing your findings with us. This is so fascinating and so important. So thank you. I look forward to learning more as more is learned. And please come on back and share. I really enjoy these conversations. Thank you so much for what you do.
Oh, thanks, Maria. And I want to also appreciate my deeply appreciation to the UK Space Agency. So they actually funded this study, and they supported this problem first in the global level, and to basically disseminating this issue to globally.
That's T-Minus Deep Space, brought to you by N2K Cyberwire. We'd love to know what you think of our podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing space industry. If you like our show, please share a rating and review in your podcast app, or you can send an email to space@n2k.com. We're proud that N2K Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K helps space and cybersecurity professionals grow, learn, and stay informed. As the nexus for discovery and connection, we bring you the people, the technology, and the ideas shaping the future of secure innovation. Learn how at n2k.com. N2K's senior producer is Alice Caruth. Our producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilpie is our publisher, and I'm T-Minus host, Maria Varmazis. Thank you for listening. We'll see you next time.